surprise that it's actually present. This version, the Neanderthal version, is present at a low frequency there. So it turns out then that this, what we thought was a Neanderthal-specific thing, has actually come out over to modern humans and exists in a low frequency. So that then allows you to use a questionnaire information from people in the UK Biobank. There are 19 questions that have to do with all types of pain, back pain, stomach ache, headache, and so on, and see what it associates with. And the most obvious thing that pain in your life associates with, unfortunately, is increasing age. The older you are, the more aches and pains you have, which is trivial. You have more medical problems. But more relevant then is that people that carry this Neanderthal variant here do report more pain in their lives. And if you relate this to this age effect that we can perhaps more associate something with, it is as if you were 8 years older in terms of pain in your life if you carry this Neanderthal variant. So we can, of course, from that not say that Neanderthals experienced more pain in their lives. We all know that the sense of pain is modulated at spinal cord and very much so in the brain. But it's still interesting that people who are heterozygous today, this is so rare, so of course everyone we have in the UK Biobank is heterozygous, they do report more pain in their lives. And Neanderthals were homozygous for this, so maybe we need to rethink a bit our view of Neanderthals as these brutish, insensitive individuals. Maybe they were actually very sensitive. So in the end then, I also want to discuss genetic changes that happen on the lineage to modern humans. So things that occurred in the last 500,000 years of human evolution and spread to be present in many or almost all people today. And we are very interested in those changes because we think that some of them may then be involved in functions that are unique to modern humans. And I do think that modern humans are special in some ways, because Neanderthals and Denisovans existed for hundreds of thousands of years. They probably never got more numerous than 100, 200,000 individuals at any one time. With modern humans then, after some time, at least from 70,000 years ago, technology starts changing very rapidly and become regionalized in different parts of the world. There's some indications that Neanderthals had art, but figurative art that we can immediately recognize what it depicts comes and becomes frequent in certain parts of the world, such as Southern Europe, with modern humans. And of course, most fundamentally, probably modern humans become very numerous, spread around the world, replace other forms of hominins and start spreading over open water and colonized every part of the world where you can live. So an idea is that some of this sort of readiness to absorb and develop culture and technology may hide in those changes here. So you can then list them, of course, list things that became frequent in the human lineage in the last 500,000 years. And just to give you a sense for what we may do with those things, if we look on one amino acid change, such change, which is in an enzyme, glutathione reductase. There's an amino acid substitution there, and this enzyme then reduces oxidized glutathione, so it's important in taking care of oxidative radicals that are produced in all our cells by metabolism. But this enzyme, when there is no oxidized glutathione available, produces itself some oxidative radicals. So when people here at the Karolinska synthesized the Neanderthal version of this and the modern human version, you can see that the Neanderthal version is actually more leaky and produces more oxidative radicals. Then you can again go to these biobanks and find that in certain populations, this ancestral version was contributed by Neanderthals and occur in a low frequency for example, in the UK Biobank. It's very rare there, but you can then look for associations with disease in present-day people or other phenotypes. And you can then see that this variant is associated with some diseases that have to do with inflammation or have a component of inflammation, such as arteriosclerosis or inflammatory bowel disease. So I think sort of this indicates where we are going with this currently, that you can use these genomes from our closest relatives to identify things that are human-specific, to find things that are Neanderthal or Denisovan specific, and you can use this gene flow from these groups where they introduced either Neanderthal-specific things or archaic things into humans to then study their effects in people alive today. But you can also, of course, do experiments, for example, by ancestralizing human cells back by CRISPR technology and study their effects in tissue culture, and even make animal models that you humanize or ancestralize for different things of these things.